So now we're going to talk about compound inequalities. In our last video, we did a quick introduction to inequalities, and that was probably a review for a lot of you. These might be a little bit more complicated, but I want to do a quick review first on something called interval notation, okay? And that just has to do, again, hopefully this is a review, but this has to do with how you can write your answers down, okay? A lot of times with inequalities, since you have more than one answer, and as a matter of fact, technically with these, you have an infinite number of answers. We have to think of a different way to write our answer down. We don't just have x is equal to 6 and x is equal to 3, for example, where we only have to write down a finite number of answers. We have an infinite number of answers we have to write down, so we have to find a new way of including, or of writing our answers, okay? And one of the ways we do this is using something called interval notation, okay? So what we do is we use parentheses and brackets to do this. All right, so I've written a couple examples here. The first one we have x is less than or equal to 7. Okay, so we have all values of x less than or equal to 7. So if you have x less than or equal to 7, it's everything up to and including 7. So what we'll notice is that anytime you have infinity on one end of your notation, you'll see this here, 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 or here. We have negative infinity, and then both positive infinities. You're always going to use a parentheses next to the infinity, okay? That is important, okay? And then whether or not you use a bracket or a parentheses next to the number has to do with this sign here. If it's less than or equal to, you're going to use a bracket, okay? And if it's strictly less than, like here, you're going to use a parentheses, all right? And then the same go in the other direction as well. If x is greater than or equal to 6, you're going to use a bracket, and if x is strictly greater than 6, you'll use a parentheses, okay? So that's just a quick review on how you would write things in interval notation. Alex is going to want you to answer some of these in interval notation. If you're interested in having a review on interval notation, feel free to reach out, and I'm happy to make a more in-depth video on this. But I just wanted to do a quick reminder of how interval notation works. Okay, but let's look at a few examples. Okay, so when you're dealing with compound inequalities, you have to pay very close attention to how the inequality is worded. Okay, and what I'm speaking of here is this word here. Okay, so in some cases you'll see the word or, and in other cases you'll see the word and. Okay, if you have the word or, this implies that it has to be the inequality you're looking for. Sorry, let me see how to write this. Or implies that you are looking for all values that satisfy either inequality. Okay, so they don't have to necessarily satisfy both of them. Okay, so the keyword here, I can't even spell. Sorry about that. Either. Okay, the keyword here is either. That is your keyword here. Either inequality. Okay. So you're looking for all values of your variable that satisfy either inequality. They don't have to satisfy them both. They can satisfy them both, but they don't have to. Okay, it can be true for one and not true for the other, and that can be included in your answer. The word "and" implies that you are looking for all values that satisfy both inequalities at the same time. Okay, so that word there is really important. So if you have or, you're looking for one that satisfies either inequality, and implies that you are looking for all values that satisfy both inequalities at the same time. So for this one, we have 4w plus 2 is less than or equal to 10, or negative 2w is greater than or equal to negative 10. Okay, I'm actually going to swap these here so we have more room. Okay, so let's go ahead and see if we can solve these. When you get something like this, you want to try and solve each of the inequalities. So let's go ahead and do that. This left one here, we'll take 2 away. We'll take 2 away from both sides. And we'll have 4w is less than or equal to 8. Now we can divide both sides by 4. And we'll get that w is less than or equal to 2. And then over here, we can just go ahead and divide both sides by negative 2. But remember, since we're dividing by a negative, we have to flip the sign. So now we have w is less than or equal to 5. Okay? So the inequality that we're looking for here is w is less than or equal to 2, or w is less than or equal to 5. Okay? So when you're trying to figure out how you want to write your final answer here, what I do is I actually just like to write each of these in interval notation and figure out what the overlap is, okay? Or in this case, well, let me if you're doing and. For in this case, we're doing or. So we'll just go ahead and do it. So we have, in this case, we have negative infinity to 2, okay? We're going to use a bracket here. And then in this one, we have w is less than or equal to 5. So we have negative infinity, the parentheses, to 5. Okay? Do a better bracket. There we go. So w is less than or equal to 5. Okay? And we want all values that satisfy either of these inequalities at the same, or really independent of each other. Okay? So to see how this works, I guess in concept, sometimes it helps to do a number line here. Okay? So we have for this left one here, we have negative infinity to 2. So we'll just label our important points here, 2 and 5. Okay, so we will do everything less than or equal to 2. Okay, and then here we'll do everything less than or equal to 5. Okay, so since we want to consider everything that satisfies either of these inequalities, we can union these two together. Okay, so this would be negative infinity to 2 union with negative infinity to 5. Okay, and if you union these two together, you'll actually just get this inequality on the right here back. Okay. So your final answer will actually just be negative infinity to 5. Okay? Not, or, including 5. So that would be your final answer here. And to see the logic for this, so you can pull any value from here, and obviously it would make sense. Okay? But you can also pull values from here, because remember, it does not have to satisfy both inequalities at the same time. It only has to satisfy one of them. So your final answer is actually just going to be negative infinity to 5. So now let's look at this one. We have 3u minus 4 is greater than or equal to 5, or 2u minus 5 is less than or equal to negative 13. So let's go ahead and add the 4 to both sides. So now we have 3u is greater than or equal to 9. So now we can divide both sides by 3, and we have u is greater than or equal to 3. Okay, so let's write that in interval notation. So we have all values of u that are greater than or equal to 3. So we'll do a bracket, then 3, and then we'll have infinity. Over here, can add 5, and we'll get 2u is less than or equal to -8. Okay, can divide both sides by 2, and we have u is less than or equal to -4. So we can write this one as -infinity to -4, where we include -4. Okay, so let's take a look at this on the number line. All right, so let's do our two relevant points. We have -4, and we have 3. So if we were to graph 3 to infinity, we would have closed dot here, and then everything to the right. And if we do -infinity to -4, we'd have a closed dot here, and then everything to the left. Okay, but remember, our key word here is or. Okay, so we want to find out all values of u that satisfy either of these inequalities. So we have to include both of these. We have to include 3 to infinity, and we have to include -infinity to -4. Okay, so we have to somehow combine these two together. And we use what I showed in the previous example, this little union sign here. Okay, this means that we're bringing these two intervals together. So we can actually write this as -infinity to -4 unioned with 3 to infinity. Okay, so those are all of the values that would satisfy either of these inequalities. Now let's look at an example where we have to find everything that satisfies both of them at the same time. So here we have 4v minus 5 is strictly greater than 19. And then we have 3v plus 5 is strictly less than -10. So let's try to solve these. So let's add 5 to both sides here. And we'll get 4v is strictly greater than 24. Divide both sides by 4. And then we get v is strictly greater than 6. Okay? And over here, we can take 5 away. And we get 3v strictly less than -15. Divide both sides by 3. And we'll get v is strictly less than -5. Okay, so let's go ahead and do each of these in interval notation. So we have 6 to infinity, and then here we have -infinity to -5. Now, anytime you have a situation where you see the word "and," it can be very helpful to graph these on a number line. And then what I do is I just see where the overlap is, and that's going to be your answer. Okay, so let's do that now. So our relevant values are -5 and 6. Okay, so we want everything from 6 to infinity. So if we're doing this in a number line, since we're not including the point 6, we'll do an open circle here, and we'll include everything to the right. And then here, -5 or -infinity to -5, we'll do an open circle here and include everything to the left. And we're looking for the overlap between these two, which in this case doesn't exist. Okay, and in a situation where it doesn't exist, you are going to end up actually just having no solution. Okay, or sometimes we use a symbol looks like this, and this just implies no solution, or we call this the empty set if you're going to use set theoretic notation. This means there's no numbers in that set, basically. That's what that symbol means. Okay, so there's two ways you can write this. I think Alex wants you to use this symbol here, But if you were on a test or something, you could write no solution, and that would be totally fine. But it just means that there are no values that are going to satisfy both of these at the same time. Okay, and a way of writing this in interval notation, we can write this as negative infinity to -5, and we do something called the intersection, and it's this big upside down U looking thing. So we have negative infinity to -5 intersected with 6 to infinity. And this symbol here means all values that are in both of these sets at the same time. But we've already shown via the number line here that there are none. Okay, there are no values that are in both of these at the same time. So we say no solution. All right, so let's take a look at this one. Here we have -2u is strictly less than -6, and 4u minus 3 is greater than or equal to -7. All right, so let's go ahead and solve this one. We can divide both sides by -2. And remember, we have to flip our sign. So now we have u is strictly greater than +3, because -6 divided by -2 is +3. Now here we can add 3 to both sides, and we'll get 4u is greater than or equal to -4. So we can divide both sides by 4, and we'll get u is greater than or equal to -1. Okay, so here we are not including 0.3, so of 3 onto infinity. And here we are including the point -1. So we have -1 to infinity. Okay. So now what we're going to do is we're going to figure out which values satisfy both of these at the same time. Okay? And we'll figure out what the overlap is. So we're going to do a couple of number lines here to show this one. All right, so here we'll write down our relevant values. We have -1, we have 3. All right, we want from -1 to infinity. We're going to fill in that dot because we're including the point -1. And we have everything greater than -1. Now we'll do the other one. So here we have our relevant values -1 and 3. And we will have an open dot at the point 3. And we'll have everything greater than that value. I want to figure out what the overlap is. So we can see pretty easily that the overlap between these two is everything here. Okay, but we're not including that point 3. So that means we're just going to have 3 to infinity for our final answer. So our answer here is 3 to infinity.